Hello everyone, welcome back to the channel. So in this video I'll be solving the problem B, which is sum of two numbers from Codeforces round 851. So let's start understanding by the problem statement. The problem statement goes like: the sum of digits of a non-negative integer a is the result of summing up its digit together when they are written in decimal form. So what they're saying here is that, let's suppose we are given a number 1, 2, 3. So they have defined the sum of digit as the sum of individual digits of the given number. Like here 1, 2, 3, we can get 3 plus 2 plus 1 equals to 6. Okay. And what we have to find here is the given an integer and find two non-negative integers x and y that satisfy the following conditions. So we are given an integer n and we have to find two integers x and y such that their sum should be equals to n, and the sum of digits of x and sum of digits of y should differ at most 1. So what they are saying that break n into two parts such that the sum of x and y should be equal to n, and the difference between the sum of digit of x and y should be at most 1. It could be either 0 or either 1. Okay, so I hope the problem statement is clear. So let's move to the concept part of this problem. So I'm taking the test cases which are given in the as sample test cases. So here we are given some numbers like 1, 16167, 1206, and our task is to distribute or divide these numbers in two parts, x and y, such that the sum of x and y should be equals to that given number, which is n itself, and the sum of digits of x and y should differ at most 1. It could be either 0 or either 1. So there are two possibilities here, that whether my given number will be odd or it can be even. So for even case, the case is very simple, that we can divide simply by n by 2 and n by 2. We can say that it is obvious to divide n by 2 as per the given conditions. Like 24, then we can divide it as n by 2, which is 12 and 12. So the sum of 12 and 12 will be 24, and the difference between the sum of digits of these two numbers, like here 3, 2 plus 1 3, and 2 plus 1 3 is equals to 0. 3 minus 3 equals to 0. So here the condition is satisfied. When the number is even, you can divide equally. And the complicated case is for odd numbers. So let's see what we can do for the odd numbers. Suppose we are given 2, 4, 3, 7 and 9. So this is an odd number, and we have to divide this number in two parts, x and y. So try to see this problem in this way, that focus on the individual digits. So can't we say that if we divide the individual digits, like here 2, then I can divide 2 as 1 and 1. So if we divide each digit equally among x and y, and when we sum this, then 1 plus 1 2, we will get 2 in this place. For 4, we will divide 2 and 2. So when we will sum this, we will get 4 here in this place, second place. So for the even digits, the case is simple. We will divide equally x by 2 and x by 2. So sorry, x is here already. So you can say that we can divide digits equally among x and y. And what if we tackle a odd digit? What we can do in this case? For odd digit, we have to keep a difference of 1 on either this side or this side. For example, we can divide 3 among x and y. We can't divide equally, but we can divide them efficiently by keeping the difference of 1. What I mean by saying that is, for 3 we can either divide it as 1 and 2 or 2 or 1. So here we are keeping one extra number on this side, and for 2 and 1 we are keeping one extra number on this side. And so let's suppose we are taking this number 1 and 2. So we have divided 3 as 1 and 2. So when we will add these two numbers 1 and 2, we will get 3 on this place, and again we are getting 7, which is odd. So you can say that previously we have taken one extra number on this side, okay, by keeping 1 on this side and 2 on this side. So, and when we will get another odd number, then we will try to put that extra number on this side, because previously we have put in one extra on this side, and if this time we put an extra number this side, then they will balance each other. Like here 7, so we can divide 7 as 4 and 3 here. So you can see that here we have divided 7 as 4 and 3 by keeping one extra number on this side. Previously we have taken one extra number this side, and this time we have taken one extra on this side. So they will cancel each other by after taking the difference. So the difference between the sum of digits should be 0. And what if we get again odd number? So you will ask that what we can do, on which side we will keep this, the extra one which will we get from the another odd number which we are tackling here. So you can put that on either side, because previously we have balanced like by putting one on this side and again putting one on this side. So in this time you can put on either side. Like for 9 we can break it in 4 and 5. So we have kept 5, like one extra number on this side. So if for the next time if we get an odd number, we will try to put the extra part on this side so that they will balance each other. So you can see here that if we are getting the odd ones odd number of times, like here 3, 7 and 9, so we are left with one extra number on this side. There is no balance of that on this side. Okay, so when you will take the difference of sum of these numbers and these numbers, you will get absolute value of 1 here. So that's why they have said here that the sum of digit of x and sum of digit of y should differ at most 1. It could be either 0. So 0 will be in the case when we will getting the odd numbers even number of times, odd digits even number of times, and it will be 1 when we are getting the odd digits odd number of times. So I hope this is clear to you that why they are saying that the difference should be at most 1. I know that this is of no use that much, but I have explained it for the sake of your understanding. So I hope the logic of this problem is clear to you, that how we will approach the problem. So if the given number is even, then simply print n by 2 n by 2, and if the number is odd, then start traversing the number from left. Okay, like here let's suppose the number is 4, 2, 3 and 8 and 9. This number is odd. Then start traversing from the left side here and take 2 strings for the convenience. Take strings. So typecast from string to char and char to string, that you will do, I know. And start traversing the number from left to right. So here I have tackled 4. So 4 will be divided as 2 and 2. And again we have got 2. So 2 will be divided as 1 and 1. And here we will tackle an odd number. So for as I have explained you previously, that for each time we have to change the direction. Like if previously we have kept the one extra part on this side, then next time we have to keep the extra part on this side. So you can take a flag variable, okay, or flag value. Flag will be equals to 0 initially, or you can take 1. So after each iteration, like after dividing this, you can change the value of flag to flag equals to 1 minus flag. So what will happen by this is, your flag, if it was previously 1, then it will change to 0, and if it was 0 previously, then it will change to 1. So by creating this gate, so you can keep one extra part on this side for the one time, and for the next time you can keep the one extra part on this side. Okay, I hope this is clear to you. So for example, this is 3, then we can divide it as 1 and 2. So, and if you are tackling an odd number, then change the value of flag. Okay, so here the flag value will be equals to 0, and after doing this, the flag value will become 1. So for the next time, if flag value is 1, then I will add 1 extra to this side. So here it is even. So even will be divided equally, 4 and 4 and 9. So we have kept the extra part on this side previously. For this time my flag value is 1, so I will keep the extra part on this side. Okay, this side. So 9 will be divided as what we can do, 5 and 4. So this is how you can divide the numbers. 2, 1. So what will the difference between the sum of digits of these two? 5, 4, 9, 1, 10, 10, 11, 12, 13. So here the sum is 13, and here 4, 4, 8, 10, 12, 1, 13. So here you can say that the difference is 0. Why? Because the even odd numbers are occurring even number of times. Like here 3 and 9 are odd, and they are occurring two times. So yeah, this was the approach of this problem. One more case will be here. Like for example, you are getting number like 1, 2 and 3. So if you divide 1, you can divide as 1 and 0, and 2 will be divided as 1 and 1, 3 will be divided as 2 and no, you have kept the one extra part on this side previously, so you have to keep extra part on this side this time. So you can see here that the sum is 3, and here also sum is 3, so difference is 0. So here you can say that leading 0 is occurring. So what you can do is reverse this number and pop this 0 simply. Okay, So this was all about this problem, guys. I will show you the code of this problem, what I have done. Okay, here I have taken x and I have divided the number as x by 2 and x by 2 plus 1. You can see here that this will either give 0 or 1. If it will be odd, then it will be y will be x by 2 plus 1. Okay, and here is the flag variable which I was talking about. If my flag variable is 0, then I will add a plus x and b plus y, and if flag variable is 1, then I will add a plus y and b plus x, and if x does not equals to y, then change the flag variable. Okay, and this was the case for the leading zeros. You can reverse the number and pop back and again reverse. So this is the modify function which I have created, and here I have taken the string as input. I have taken the number as a string, and I have taken two empty strings a and b, and I have called the function for computing my answer, like here for adding the numbers, dividing them equally among a and b, and then I'm modifying the number for removing the leading zeros, and then I'm printing the number. Okay, so this was all about this problem, guys. Thank you for watching the video.